Topic 1, Day 6, Logarithm Rules. If we consider the equation 10 to the power of x equals 100, can we think of a value of x that makes this equation true? Hopefully, you're thinking 10 squared or 10 times 10 equals 100, so x is equal to 2. Cool, we can do that. Now consider 10 to the x is equal to 50. Why is this harder to solve? Well, solving each of these equations require us to ask the question, what power should 10 be raised to in order to get 100 or 50 or whatever value we're looking for? Logarithm allows us to write this question using symbols. So the power to which you need to raise 10 in order to get 50 is written as log base 10 of 50. And the numbers that you enter into the logarithms are named. For log base a of b equals x, a is the base, b is the argument, and x is your answer. In order to convert from exponential to logarithmic form, we can use this equation here. So this first part, when your x is in the exponent, this is our exponential form. And then the second one, where there is a logarithm, is our logarithmic form. Okay. And what you'll see is a is always our base right here. And then b is our answer. And then x. There we go. Or b is the argument and x is the answer. Okay. There are 4 logarithm rules that we should be familiar with. They are on your equation sheets, however, for both pre-calc and for IB. So you should be familiar with them, but you don't have to memorize them. However, because if you take analysis next year, if you take IB analysis, there are times where you will have no calculator sections of tests or questions, and it's pretty common to have some logarithm questions that are no calculator, okay? Additionally, if you see log b and it doesn't specifically indicate the base, you should interpret it as base 10, so log base 10 of b. In addition to base 10, natural logarithms, or base e, is also very, very common. So e, like pi, is an irrational number and is approximately equal to 2.71828. All right, e is considered natural just because it comes up in nature so often, right? So we use it in compound interest, carbon dating, bell curves, exponential growth, and decay. So if you have e, which is our 2.7 value, to the power of x equals b, we can convert that into logarithmic form. X equals log base e of b, and this log base e we shorten as natural log, which is ln. Okay, teacher example number 1 asks us to convert natural log 2 equals c into exponential form. So we have ln of 2 equals c. We know that ln is the same as writing log base e of 2. And here we can take our conversion, right? We're going to convert it into exponential form. E to the c power equals 2. All right, and that's it in exponential form. Go ahead and try student example number 1 on your own. Teacher example number 2 asks us to condense this expression, negative 2 log base b of x plus 5 log base b of x. What we'll see is that we have a negative 2 and a 5 acting as coefficients out in front. If we look at our power rule, we'll see that when we have that coefficient out in front, we can also rewrite it as x to that coefficient's power. So I'm actually going to rewrite this as log base b x to the negative second power plus log base b x to the fifth power. And this is going to be using our power rule. Okay, and now since we are adding here, we know that we can use the product rule. And when things are being added, our x's and y's there are going to be multiplied. So that's what we're going to do next. Combine these, log base b x to the negative second times x to the fifth power. And we can simplify that. We get log base b x to the third power, right? Since that is completely simplified, we're going to just put that exponent back out in front, and we'll get 3 log base b of x. Okay, go ahead and try student example number 2 on your own. So our last teacher example number 3, it says to expand log base b x to the third over x squared. So what I'm going to do first is since it's being divided, we're going to use our quotient rule and rewrite it so that we have log base x to the third power minus log base b y squared. And then since we have those exponents, we're going to rewrite them out in front. 3 log base b of x minus 2 log base b of y. And that's completely expanded. Go ahead and try student example 3 on your own.